Binary logistic regression with one continuous predictor or one binary predictor in JAMOVI. Binary logistic regression with a continuous predictor in JAMOVI. Binary logistic regression is a statistical method that can be used to find a relationship or association between two variables. One of the variable is the outcome, or it is called a response variable or the dependent variable. This outcome variable have to be binary. Binary variable have only two levels in it. Have the diabetes, no diabetes, heart diseases, no heart diseases, yes or no, smokes, doesn't smoke. The second variable is the predictor, or alternatively it is called the explanatory factor or variable, the independent variable or the exposure variable. The main reason to use this test is to find out whether there is association between predictor and outcome, and whether the predictor can predict the outcome, and whether the variation in the outcome can be explained by the predictor. The predictor can be a continuous variable, can be binary variable, can be a multinomial variable, or it can be ordinal variable. Continuous predictor is a variable that have a scale data in it, measured at either an interval or a ratio level. Here in JAMOVI data sheet, I had inserted two variables. The first one is the age, the second one is the heart diseases. There are 100 cases in this data sheet. So here we have two variables. The first variable is age, and it is a continuous variable. It's measured at a scale. And a second variable, which is the heart diseases, is a binary variable or binomial variable, as it has only two levels in it, whether you have the heart diseases or no heart diseases. To find out whether there is association between age or increasing age with the probability or the possibility of having heart diseases, then the binary logistic regression can be used, as the outcome here, which is the heart diseases, is binary, and the predictor, which is the age, is a continuous. Before we proceed to the test, let's look at some descriptive statistics by clicking on exploration, then descriptive. In this window, drag the age into the variable section and the heart diseases into the variable section. As shown here, I'm going to trim some of the things here, like I don't want the median, the mean, and I don't want the standard deviation. As shown here in this table, there are 100 cases, no missing values. If I click on the frequency table or tables, again a second table is generated. So in the first table, the age has a minimum value of 18 years old and a maximum age of 94 years old. For the second table, which is the heart diseases, there are 44% of the cases have no heart diseases and 56 have heart diseases. To find out whether the age can predict the heart diseases, we will do a binary logistic regression, as the criteria or the condition is set for that test. To do that, click on regression here, scroll down to two outcomes, binomial, and in this new window here for binomial or binary logistic regression, drag the age, which is a predictor into the covariate section, and the outcome, which is the heart diseases, into the dependent variable. Spontaneously, a few tables are generated, but let's scroll down here and see if we need to select any of these options here. For the reference level, no heart diseases is set at a reference level, or we can swap it to set the reference category as heart disease, but here we'll stick with no heart diseases. For the option of assumption check, we'll not look at it at this stage. Model fits, I'm going to tick on the Cox Snell R Square, and also the other one for R Square here. For a model coefficient, definitely we'll look at the odds ratio to generate an odd ratio as shown here. We will give it also a confidence interval for that odds ratio. We'll not at this stage look at these. For the estimate marginal, nothing to select from. For prediction, let's go for classification table. And finally, for save, we'll stick what we have in the output. Again, as shown here, from the output for the binomial logistic regression in JAMOVI, multiple tables are generated. The first table here is the model fit measures. We're going to look at this R square here. This R square, which is equal to 0.774, indicates, or it means that 77.4% of that variation in the outcome, which is heart diseases, can be explained by the age predictor. So there is association between the age and the heart diseases or the outcome. Moving to the second section here as shown in this table, it is the model coefficient heart disease. We will ignore the intercept value, but we will look at the age values. Here is the estimate for coefficient. Here is the standard error, the z-score, the p-value, the odds ratio or exponential b, and the 95% confidence interval. And a footnote is produced here, represent odd ratio versus no. So it is the odds, log odds ratio of heart diseases to no heart diseases. From the p-value here, it shows that there is a significant association between the age predictor and the outcome, which is the heart diseases. This is also confirmed by the 95% confidence interval for the odds ratio, in which the 1.2 fit within the upper and lower limit. So to start with, there is a relationship between age and heart diseases, or chances or likelihood of having heart diseases. The way to interpret this table is that for each unit of age, which is 1 year, there is an increased odds of 1.2 of having heart diseases, and this association is significant. In another way, for every year increase in age, there is a 20% chances of having heart diseases. 20% is calculated by subtracting from 1.21, and that will end up in 0.2. Multiply that by 100, so it is 20%. So there is, from this table, there is an increased chance of developing heart diseases with increased age. So age is a factor that can predict or explain the variation in the outcome, which is the heart diseases. So this is the way to perform binary logistic regression with a predictor that is continuous in JAMOVI. Binary logistic regression with binary predictor in JAMOVI. Here in JAMOVI datasheet, I had inserted 100 cases, and there are two variables. The first variable is the gender and have two levels in it, males and females. And a second variable, which is the heart diseases, whether you have heart diseases or no heart diseases. So the sex here variable is a binary variable, and the heart disease is also a binary variable. But the heart diseases here is an outcome, as we want to find out what is the chance of developing heart diseases. So here we have one outcome, which is binary, and predictor, which is again binary, as it has two levels in it. So these two variables are both binary. To find out whether there is association between gender and possibility of developing heart diseases, or whether one of the sex have higher probability or higher chances or higher likelihood of developing heart diseases than the other, then the best test to go for is binary logistic regression. Before we perform and do the test, let's look at some descriptive statistics by clicking on exploration, select on descriptive, and then let's drag the sex to the box of variables and the heart diseases into the box of variables, and then tick on the frequency table here, and from statistics we'll remove the median and the mean, as both variable are categorical, i.e. binary, has two levels in it. We don't need the standard deviation, no need for minimum and maximum. So looking at the output from the descriptive statistics here, the first table shows that there are 100 cases. There is no missing cases for any variable. This is a good sign. For the frequencies, it shows that there are more females than males. 52% are females and 48% are males. For heart diseases, there are more heart diseases cases than non-heart diseases. 56% of cases have heart diseases and 44% don't have heart diseases. To perform binary logistic regression, click on regression here and then select two outcomes binomial for regression. If this function is not available here in the menu, click on the module here and then add that through the JAMOVI library. So back again to regression, click on outcome for binomial regression. A new window is generated. Here we can see that we have two variables. We'll move the outcome, which is the dependent variable, into the dependent variable, and sex we will move it into the factor here. Since it is binary, let's select some options from the list here. For model builder, nothing to choose from. For the reference levels, since we have two variables, both variables are binary. For the heart diseases, the no heart diseases will be the reference category to compare to, and for the sex variable, the females will be as set as a reference category, and the males will be compared to females. For the assumption checks, no, we'll not look at it at this stage. For model fit, tick on the Cox Snell R Square and the other R Square. For the model coefficient, tick on the odds ratio and the 95% confidence interval. Looking at the output from the JAMOVI section here, there are multiple tables. The first table is the model fit measures. Looking at the R square value here, which is 0.735, this R square means that 73.5% of the variation in the outcome, which is the heart diseases, can be explained by the predictor which is the sex or the gender of the individual. This is a high value. Moving to the second table, which is the model coefficient for, again here, heart diseases. So we are here looking at heart diseases, and that's what we will interpret from this table. For the predictor section, males to females. Again, the females will be the reference group here, so male will be compared to females. The estimate, which is the coefficient, is given here, the standard error, the z-score, the p-value, the odds ratio, and the 95% confidence interval for the odds ratio. So here we have two levels of determining whether there is significance or not. P-value, if it is less than 0.05, then it is significant. And the 95% confidence interval, in which the odds ratio should fit between the lower and the upper limits for that confidence interval. From this table, it is well shown that there is a significant association between the gender and probability or possibility or likelihood of developing heart diseases, as the p-value is significant and the odds ratio fell between the 95% confidence interval. So essentially, yes, there is this test will answer the question, yes, there is association between individual gender and the probability of getting heart diseases or the odds of hitting heart diseases. The way to interpret this table is that males have a higher probability or likelihood of getting heart diseases than females, and this probability is significant. In another way, males are more likely to develop heart diseases than females, with an odds ratio of 224.5. So from this table, males having a higher likelihood or probability of developing heart diseases. So this is the way to perform binary logistic regression in JAMOVI with a predictor that is binary, that is made up of or consists of two categories. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, JAMOVI, R Statistic or Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, JAMOVI, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.